Hello and welcome. We are finally starting Unit 5 today. So we're going to step 22, which is called Angles of Polygons. So this unit is a combination of Chapter 6 and Chapter 10. We're going to cover Chapter 6. Chapter 10 is covered in the independent assignments. So we're only going to have 3 steps here before the next test. And then we're going to move on to Unit 6. So step 22 says I can find the sum of the measures of the interior and exterior angles of a polygon. So this comes from your book. If you're interested, it's Chapter 6, Section 1. We're going to talk today, so this unit is more about quadrilaterals, which we will get plenty into in steps 23 and 24. So we're just going to start out with the basic idea, remembering what a polygon is, how to name polygons, and start talking about their angles. So remember, a polygon is a shape that just it's closed, there's no sides that extend out, and the biggest thing is that it doesn't have a curved edge. So the first thing we want to talk about polygons is what a diagonal is. So a diagonal just connects two non-consecutive vertices. Two non-consecutive vertices. So that just means they're just not right next to each other. This will come in handy in step 23 once we start talking about parallelograms and the relationship between the diagonals and stuff. So this chart right here comes from like step 3, I think. Step 3 or 4, where we talked about just naming two-dimensional figures, what it takes to be a polygon. I just really copied it over from those notes. So this would be something that you might want to look at and refresh your memory on how to name polygons. Remember, they're just named by the number of sides that they have. So you guys all know triangle, probably quadrilateral, pentagon, hexagon, octagon, probably, maybe decagon. This is not a bad idea to look at. So remember, anything over 12 is just called an n-gon. So if it had 15 sides, it would be a 15-gon. But just keep that in mind as we go through this, okay? So our first theorem, we're really only going to talk about 2 theorems today. The first one is the sum of the interior angles, okay? So make a note of that. This is the interior angles. So these are the angles on the inside, just like the inside of your house. The interior would be the inside. The equation for this is n minus 2 times 180. You're probably thinking, okay, well, what the heck is n? N is just the number of sides. Okay, so if we start out super easy, let's think about like a triangle. Okay, a triangle has 3 sides, so n would be equal to 3. When we plug this into our equation, so the sum of the interior angles would be n, which is 3, minus 2 times 180, okay? So if you don't already have your calculator out, this is probably one you can do in your head, but you're definitely going to need a calculator for the rest of the video. So 3 minus 2 would be 1. 1 times 180 is just 180, okay? Which this is something we already know, right? All 3 angles of a triangle should always add up to 180, so it makes sense, right? By this equation. So you're literally, if it tells you like a hexagon, you need to know that that's 6 sides, or if it just gives you the figure, then count the sides and plug it into the equation. So the number of sides minus 2 times 180. Okay, so for A, we want to find the sum of the measures of the interior angles of a convex heptagon. Okay, a heptagon has 7 sides, if you forgot. Okay, feel free. You can use this chart for your practice and stuff. If it says like a hendecagon or something like that and you're not sure, feel free to use that. So a heptagon has 7 sides. So that means n is equal to 7. So we would take our n, which is 7, minus 2 times 180. And you can plug this in your calculator just like that if you remember the parentheses, or you can think in your head 7 minus 2 is 5. 5 times 180 is 900. So what that means is, excuse me, if we added up all the angles in a heptagon, regardless of the shape, as long as it's convex, all of the 7 angles should add up to 900 degrees. Okay, so let's take a look at number B, 1B, I guess. Find the measure of each interior angle of the quadrilateral. So if you saw quadrilateral and you're like, I don't remember how many sides, well, this one gives us a nice figure, okay? So a quadrilateral has 4 sides, okay? So n is going to be equal to 4. So we could do 4 minus 2 times 180, right? Number of sides minus 2 times 180. Well, 4 minus 2 is 2. 2 times 180, so double it, would be 360. Okay, this is one that you might want to remember. We already know our triangles. Quadrilaterals are just right behind it. Quadrilaterals for the rest of this unit are going to come up a lot. So this might be one, when you see a quadrilateral, just remember that the angles would add up to 360. Okay, so now we know that angle A plus angle B plus angle C plus angle D should all add up to 360. So 3x plus, and then angle B would be 90, angle C would be 90, and angle D would be x. All right, so I got 4x plus 180 equals 360. Subtract my 180 over, so 4x equals 180. Divide by 4, 180 equals, just checking myself, 45. Okay, so x is 45, but it says that we want to find the measure of each interior angle. So let's just start at A and rotate around. Angle A is 3x, so 3 times 45, which I believe is 135. Yep, 135. Angle B is still just 90. Angle C, same thing. And angle D would be x, which is 45. And we could always check ourselves, right? Because if we know that they should all add up to 360, we could do 135 plus 90 plus 90 plus 45, see if we get back to 360, and we do. All right, so I'm going to skip the next couple just so we can make this video as kind of concise as possible. Just doing one instead of breaking it up into like 2 10-minute videos. All right, so for the next one, so we're just going to do the tense one. We'll save the other one for class. So we have the poles for a tent form the vertices of a regular hexagon. Okay, so let's pull that piece out. If it's a hexagon, hopefully this is one that you know. If not, you can kind of look at this little tent, nice little picture here. Let's see, it has 6 poles, which mean it has 6 sides. So 6 sides. So we know n should be 6. Regardless of where we're going, we know that the number of sides, because it's a hexagon, are 6. When the poles are properly positioned, what is the measure of the angle formed at the corner of the tent? Okay, so we could think, all right, well, if we know that it has 6 sides, then we can plug it in our equation and say, okay, well, the interior angle should be 6 minus 2 times 180. Okay, so 6 minus 2 is 4. 4 times 180 is 720. Okay, so all 6 of these angles should add up to 720. Okay, and the last one we actually had measurements where we could add them together, set it equal to the number, and solve. But this time we don't have that. The other key piece that we haven't recognized yet is that it says that the hexagon is regular. Okay, remember, if a polygon is regular, just write this off to the side. Okay, all sides are congruent to each other, so they're all like 4 feet. All angles are congruent, and the figure is convex. So this is pulling back, I think this is still from step 3-ish when we talked about polygons, back from our unit 1. So the big thing here, the big takeaway is obviously that we need all of our angles to be congruent. So if all the angles are the same, then we can take our 720 and divide it by 6, and they'll all have the same measurement. So 720 divided by 6 is 120. So each angle should be 120 degrees. All right, next one. All right, so it says the measure of an interior angle of a regular polygon is 135. Okay, so there's a lot in that statement, okay? Our goal here is to find the number of sides. So let's kind of break this down and see what we can reason through as we talk about this. So the measure of an interior angle. So measure of interior angles, so the sum of interior angles comes from our equation that we've been using this whole video, our n minus 2 times 180. Okay, which makes sense because if we want number of sides, this is really saying, hey, find n, because n is representing the number of sides in all of the equations we've talked about. Okay, so we're going to use this equation, and we're going to use it a little differently this time. So this time, we've used the sum of the interior angles, and the big thing is that it's a regular polygon, okay? So if it's a regular polygon, just like we did up here with our tent, if it's regular, all the angles are congruent, okay? So what we did in our little blue equation here is we took the sum of the interior angles, which is what we found, and we divided it by the number of sides. Okay, so I'm going to take the sum of the interior, and I'm going to divide it by the number of sides. That's what we did in the last one. And this is actually equal to 135. Okay. When I do this, so notice our first equation is set equal to the sum of the interior angles. I have that same expression in my green equation, but it has divided by n. So what I'm going to do is multiply both sides by n. And now I can say the sum of the interior angles is actually equal to 135n. Notice, now I have both equations equal to the sum of the interior angles. So what I'm going to do next is set these two equal to each other, right? Because these are the same. So I can say, all right, n minus 2 times 180 is actually equal to 135n. So from here, I can do this a couple different ways. What I would do first is kind of distribute this 180. So if you wanted to, you could move it out to the front if you like it better that way. 180 minus n minus 2 equals 135n. So when I distribute the 180 inside, 180n minus 360 equals 135n. Okay, From here, you could do it, like I said, a couple different ways. I'm going to subtract 180 from both sides, so I'm going to get 136, negative 136, and then 135 minus 180 is negative 45n. Divide by negative 45, and n is equal to 8. So this is an octagon. Okay. All right, so that would be our answer. We can do another example like this in class. This is probably the trickiest part of these types of problems. The biggest thing is that if you remember this equation, oh, that's not my green pen. Really, the only thing you're going to change is that 135. So n minus 2 times 180 equals, and then whatever that measurement is, times n, and then solve. Or some of you, like I know I did this in whenever I take a math class, I like to guess and check. So you could also think, okay, well, we could figure out, okay, we could start with like a nonagon. 9 minus 2 times 180 divided by 9. See if that gets you to 135. You can always guess and check. This is just the algebraic way to solve it. All right, our second and final POSH that we're going to talk about is the exterior angles, okay? So this is saying that if we extend each side out, we would create the exterior angles, okay? These exterior angles will all add up to 360. So the sum of exterior angles equals 360. This is true for any polygon, any convex polygon. They should all add up to 360, whether they have 3 sides, 7 sides, 100 sides, it does not matter. All the exterior angles will add up to 360 regardless of the number of sides. Okay, so interior was our n minus 2 times 180. Exterior will always, always, always be 360. Okay, so if we look at, oh no, I forgot example 4. If we look at A, we have all of our exterior angles labeled. Okay, now I know that they're exterior because they're on the outside of the polygon. Okay, and I know that they're angle measurements because they have their little degree symbol. Okay, I know that they're not segment lengths because of that symbol. Okay, so just to reiterate, sum of exterior angles, meaning if we add them all up, we should always get 360. Okay, so I'm just going to go ahead and start adding them up. 3x plus 10 plus 2x minus 5 plus 5x plus 2x plus 6x minus 5. And they're all going to add to 360. Even though this is a pentagon, 360. Make sure I wrote everything right. All right, so let's combine like terms. So we got 3 plus 2 plus 5 plus 2 plus 6, which is 18 x's. And then I got a positive 10 minus 5 minus 5. Oh, that cancels. So I'm left with 18x equals 360. Divide both sides by 18, and x would be, I believe, 20. And we just got to find x, so we are done. So this one's a little more straightforward because we don't have that added step of finding the sum of the angles, because if they're exterior, they're always going to be 360. So last one, find the measure of each exterior angle of a regular nonagon. So if it's a nonagon, it has 9 sides. Okay, and remember, if it's regular, all angles are congruent. Okay, so if it has 9 sides, that means it has 9 interior angles, which means it has 9 exterior angles. Number of sides, number of interior, number of exterior are all the same. So I know that they should all add up to 360. So if I take 360 divided by 9, with the number of angles I have, because they should all be the same, each exterior angle should be 40 degrees. It's a little simpler than the interior. So just to recap, if you want to put this at the bottom, I don't really care. I just want to reiterate. So sum of interior angles equals n minus 2 times 180, where n equals sides. Sum of exterior angles is just 360, regardless of the number of sides. So interior and exterior. And that's it for step 22.